Everyone, welcome to our third video for Leaving Cert Axonometric Projection. In the previous video there we worked on this worksheet here. It was an isometric projection of this bin. The three axes in the isometric are 120 degrees, 120 degrees and 120 degrees. We have our X to Y axis giving us our vertical plane, which we see as a true shape, and we see an elevation when we look in along the Z. We had our XZ giving us our horizontal plane or the floor, and when we look down along the Y we see an edge view of the green and red to the right and to the left, and we see the plan. And we used all of the correct full-size dimensions on our elevation and plan, and we fed them back in and created our 3D view. As I said, that was an isometric projection. I think in the previous video I did a diametric projection where two of these angles would be the same and one being different. And in today's tutorial I'm going to do a trimetric. So this is the object that's on for today. There's a good bit going on here, a lot of curves obviously. Trimetric meaning all three angles exposed between the X, the Y and the Z axes are different. So in this case, between the X and the Y we have 135 degrees. Between the Y and the Z we have 120 degrees. And between the X and Z here we have 105 degrees. So it's a change of angle. It's a change of angle of your viewing direction towards this, and that's also going to change the axonometric plane that's dropped in here. But it won't change the principles. Principles still remain the same. Because it's X on the left this time and Y standing up as always. Well, the vertical plane where our main elevation goes is on the XY always. So the vertical plane here is on the left side this time, unlike the last time where it was here on the right, because this was the X-axis. So in this question they gave us the X-axis here on the left side. So up there on the X to Y axis on the red plane we'll draw our main elevation. And that will be viewed actually from this direction here. Look in along the Z and project your view up and draw your elevation. The second view we'll need to draw, so there has to be two-dimensional views to feed into a three-dimensional pictorial view of the object. The second view we need then is the plan. And if we look down along the Y axis here, we'll see this red wall and the green wall, the two vertical planes. We'll see them as edge views, and we'll be looking down on the object as it sits there on the horizontal plane. To fit this on the page, I'll just zoom in and we'll have a look at the measurements, but then I just need to point out one thing about these measurements. So the only issue with the measurements here is the ones in red are the ones that will be given on the question. If you can put your A3 blank page in vertical portrait orientation, then this will probably fit. You shouldn't have a problem with fitting this, or you can use an A2 page. For me, I'm going to just split all the measurements. It's going to be quite small and hard to get the detail in, but at least it'll fit on my sheet. The red measurements are the correct ones. So the radius 50, the 30 high, the 15, the 10 millimeters here in the center, the 80 and the 40 are the correct full sizes. I'm going to have to just split everything, divide them all by 2, because I just need to fit it on my page in this orientation, just so that the camera can catch all the detail. So it's going to be quite small for me. What it's going to mean is that this guy here, a 5 millimeter circle, is going to be way too small to get any real detail in there. We'll have a look at that after. I'll zoom out again and get ready to get started on this on a blank page. So there are the measurements I'm going to use, the ones in green. So the radius 25, the 15, 5, 7, 40 and radius 20. And again, my suggestion if you're doing this at home is to turn your A3 page in a portrait orientation, and go ahead and do it on a blank page where you have plenty of space, and it's much easier to do a big drawing than a small drawing, trying to keep all the detail in there. Now to get started, so I know that now when I do this, because I'm going to split everything, it's going to be quite easy to fit it. So I'm just going to pick a position there somewhere around the center of that page. I'm going to start off with my y-axis as always. Then I'm going to have a quick look and see what does it tell me to do here. It is telling me that I want 120 degrees here to the right hand side. Now I know that that can be just achieved by putting my 30-degree set square down, because it's 90 plus 30. So just like when we do an isometric, 120 is achieved right there, just like that. So that is excuse me, that is the y-axis there, and that is the z-axis here. The x-axis is 135 degrees here on the left hand side. Two things, we can, of course, we can just go ahead and set up our protractor and work our way down from 0, working down to 135. But you might notice that what is working up from the bottom, it's 45 degrees up. So if you were thinking here, you might recognize that we could just take our 45 degree set square and one straight down there as well. So that's probably a little bit easier, I think. And there's our x-axis. So x, y, and z axis dropped in there now. We have our y being vertical. We have a 120 degree angle here between our y and our z, and we have a 135 degree angle between our y and x. And what does that give us down the ground? It gives us 105. Now I would always just do a quick check, just make sure that we got this right, we didn't make any mistake. It's very easy with a protractor sometimes. That's fine, that's 105 there. So 105 degrees on the ground. Now we're ready to move on and start drawing some of our views. The first one I'm going to do is I'm going to put in the plan. So I'm going to look down through the y-axis. I'm going to see an edge view of the vertical and invertical. I'm going to see a true shape of the horizontal. But of course, before I can do that, I need to do what we do for all these drawings. I need to drop in my axonometric plane. The 3 traces of my axonometric plane right there. So the traces, in this case again, there's no dimension given for any trace in particular. There isn't a height given for the top point. There isn't anything given at all. So we haven't got any fixed points on the trace. So we can make it any size we want. I'm going to drop this in there in maybe, I'll just pick a green color here, and there. That is the trace on the horizontal plane. And of course that trace, just like always, if I extend it, the y-axis down, it makes an angle of 90 degrees to the trace. So I'm going to go now and I'm going to draw the trace that lies on the vertical plane here, the main vertical plane. So if I look in along this guy, this z-axis here was at 30 degrees, and at 90 degrees to that z-axis is the trace. So the trace is always 90 degrees to the axis that this is opposite, which is just like this one here. There's our trace at 90 degrees to the axis. And again, we have a 45 degree axis, and we have a 45 degree trace. There's my 3 traces of the plane. Now I went a bit small with that. It'll still work out just fine. Maybe if I was doing this in an exam scenario now, this would have all been done with my 5H pencil. I might just go a little bit bigger with it, but I'm going to go ahead with it for now. There's no problem, it'll all work just fine. Just like before, what I want to do next is I want to figure out this little portion right here that sits on the ground. This triangle here. It's inside the trace, heading into the corner of that room. I'd like to get the true shape of that triangle right there that sits on the ground. So I'm going to bring it down my page. I'm going to pick a position and stop, and I'm going to rebat it back up towards myself. So bring down one side of the trace, bring down the second side of the trace, and pick a point. Pick a position just to get started with this. Now, that right there is the true length of the green line. So the green line as it is right now, right there, brought down, that's a true length. I'd like to find the center of that green line so that I can drop in my semicircle just like before. There's the center. The center of that green line gives me the center point for a semicircle that I can now draw. And that semicircle allows me to draw any 90-degree triangle based on this green line. So we know that the corner of the room is 90 degrees. We know that the corner of the room is in line with the y-axis, so I'm going to bring the y-axis down until it hits the semicircle. There. Now, that is a key point for us. I can join that corner of the room through the end of the trace. Corner of the room through the end of the trace. That's one side of the room. Just to verify here that I'm correct, if I use sliding set squares, I should have a perfect 90-degree corner. So let's just check that out. Yeah, that's perfect. So from the corner of the room through the end of the trace. This time again. And there we get basically the two walls. We get our end vertical plane standing up as an edge view. We get our vertical plane standing up as an edge view. We have our trace, and we have the true shape of that little portion of the triangle on the floor right there as it goes into the corner. We know it's a true shape because the trace is a true length and it's a perfect 90-degree angle, so we have to be looking directly down on top of it to see that. So there's our true shape of that little portion in the corner. To drop in my plan, I'm going quite small with this now, of course, so that it fits. Its radius 25 is the largest circle on this drawing, so if I go 25 each direction, I might just go ahead and use my sliding set squares here to project those lines off. At 90 degrees to one, and at 90 degrees to the other. And this radius 25, as I said, it's the largest circle that we have, and there's nothing else larger, nothing else overhanging, so I can just draw it in with full solid detail. Oh, there we are. Then, excuse me, while I'm down here now, I might just go ahead and just draw in the other. So there's the 25 is the big one, then there's one smaller one which is full solid circle, which must be this one up here, which is a radius 20, and then there's a smaller one again which must be overshadowed by this, so it is this one right here. So it's the 25 minus 7, so that's going to be, I've just changed the 15, I just rounded it off to 7 there, that's going to be 18. So I have a 25 drawn, I'm now going to draw a 20 and an 18. So if we measure out along from that center point, there's a 20, there's an 18. And you know, just for clarity here, I'm going to take away some of my shading that I had just put in there to signify the corner of the room. Just take away some of that, and it should help not to have this guy too crowded. So from the same center point, I bring it into my 20 mil, and that is the sphere. So that is going to be one full solid circle like that. And then at the 18 mil, that is the top of that conical base that we have there. So that's going to be all hidden. Now, what I always like to do, extremely light, is once I use my compass to draw the hidden, just go around it once more with the compass. And the purpose of that is, if I need to break this up, or if I need to take any reference point, and if I happen to take a line, I need a reference point right there, and it falls between my hidden strikes. Well, if it falls between them, I don't want to guess where it is, and I don't want to go back looking for my compass later. So one light circle, and then a little bit heavier on the dashes to signify hidden detail. That view, I'm going to just go ahead and I'm going to add the colour in now. I'm going to add as much colour as I need actually at the moment now. Here, that is my HP, the horizontal plane. In there I've just put the plan. I'm going to reference back to this drawing right here, according to the colour scheme I had. So the blue floor, the red on the left wall and the green on the right wall, and I'm going to add the labels now as I go. So I'll pause the video, I'll add all that in there, and then we'll resume the video and we'll start working up here to our elevation. Now to resume the video, so I'd like to just add, I've just added in a bit of colour there, so I have my horizontal plane. I've the label there for the horizontal plane. The horizontal plane, of course, is right in here as well. It's a round object, it touches both walls, but it doesn't fill all the way into the corner of the room. There isn't a 90-degree corner on the object, so it just touches both walls at those points that I originally set out. In my case, it was out 25 and out 25. They'd be the points of contact that it makes with the two walls. This green line that I've just highlighted out here is an edge view of the EVP, the end vertical plane, and this line highlighted in red here is an edge view of the VP, the vertical plane. And of course HP, I've already labelled it right there. So there's the object. There's a 2D view looking straight down on top of the object, sitting on the floor, and that's that view finished. Again, I'm just going to take away the shading I'd lightly added in right there, just for clarity here as we move on. And we're going to work on ahead there to the elevation. So the elevation of the object, if I just drop this back in here, the elevation of the object here shows the sphere again. It shows the little stand in the center, and it shows the main base. And the base is actually in the form of a cone that has been cut, so a truncated cone. The cone starts off down here at a total radius of, well, a true size of 50 there, but I've brought it down to 25, and then it gets 7 mil smaller in the radius, so 14 mil smaller total. So I'll go ahead using all the measurements I have here in green on my sheet. Hopefully for yourself you'll do it in red. Using all the measurements I have in green, I'm going to go and I'm going to look in along my Z axis. I'm going to see the floor underneath the object. I'm going to see the, you have to kind of imagine yourself standing here really looking at this, you know. This is your left hand and this is your right hand. Well, first of all, down there, the floor is still going to be the floor. It's still going to be under the object. And on your right hand side here, you're going to see the green wall. So you'll see the blue floor as a line, you'll see the green wall as a line, and we'll see a true shape of the red vertical plane. Let's get started in that one. Because of the way the axes are set out here, and this one being 120, we want a view in along the Z axis, so that's just going to be using our 30-degree set square, which is quite handy. I'm going to take the 2 points on the trace, and I'm going to pick a starting position anywhere at all out here. Now, that starting position is parallel to the trace, and it is the same length as the trace. So, there we go, that's a true length of the trace. What we want next is we want to rabat this triangular surface that goes into the corner here. And as we know, that true angle of that small triangle in there is 90 degrees. The true angle up here is 90. It appears right now as 135 degrees, but in reality it has to be 90. We want our 90-degree triangle that catches that point based on the green line. So let's go ahead and let's get our bisect and our semicircle first. Very important in an exam question that you show the compass strikes. Otherwise it looks like you've just guessed the centre and you won't get construction marks. You have to show your compass strikes and show your construction line that goes in to establish the centre. That has to be seen in an exam question. Now hopefully that can be seen there on the camera. Now, every possible triangle that I draw now based on that green line that touches the circumference of that arc is going to be perfect 90 degrees, but the only one that I want, I don't want every possible answer, I want one answer, the one that lines up with the corner here. So that's going to be the corner of the room up there as I look up at the two walls. And I'm going to draw first of all from the corner of the room through the trace, so through the end of the trace here, and extend on up. So from the corner of the room up through the end of the trace right there. And I'm now going to go ahead and draw from the corner of the room out through the other end of the trace here, and it should be, and it is, a perfect 90 degrees to it. And as I said last time, I like to verify that by using my sliding set squares. So draw that first line. Now if you're not sure, I was pretty confident that was going to end up working, so I was able to just go straight in with my H pencil. Maybe use your 5H, test out the first line, slide up and test out the second line just to make sure it's all perfect. Go back and see what went wrong if it wasn't, if it doesn't end up being a perfect 90 degree angle, but it should be. What I've now found is I've found this triangle here as a true shape. That is a true shape right there of what happens, what the triangle looks like under the trace heading into the corner. Now, time to just drop in my elevation up there. Time to drop in the elevation. Again, I'll just get rid of this bit of shading I had added in here. I'll drop in the elevation using the measurements given. The measurements given on the heights. The heights are quite simple. In this case, it's a height of 15 is what I'm using again in green. So it's 15, and then it's 40 up to the center of a radius 20. And then the widths are going to be the same as the plan, you know, so it's going to be a radius 25 from me. So in 25 to halfway, and it gives me a central axis up through the object. I'm going to box in this view here, and then I'm going to measure in 7 each side. Or I might do it a different way. There's actually a much more accurate way that I might do this now as well. I'll just get started, start laying it out, and then I'll have a chat about finding just this point here in a more accurate way in just a minute. First thing I'm going to do is I'm going to just set my adjustable set square to the angle of the floor and the wall there, because it'll just save me a fair bit of time. So there's the angle of the horizontal plane. I think that's pretty accurate. Yeah, that looks good. And that will also give me the angle there of the vertical. So I'm going to go ahead and measure I only have two heights, I think, for me, 15 and 40. And on the widths, just the 25 is all I want for now. I'm going to draw from the 25 central line that goes up through the whole object. From the 15, I'll just come across, and from the 40, I'll just come across as well. Now I know at the 40 mil mark up there, this top mark, I can draw the sphere. A sphere is a circle in every view, so it's not going to change size up there either. So down in plan, that sphere was drawn to size 20, radius 20. So up here in the elevation, it's going to be drawn to radius 20 as well. So there's the sphere dropped in. Next thing I'm going to do is this. I'm going to just work symmetrically. I know that that's the center of the object. I know that that's one side of the base, and that has to be the other side of the base. But I also know is this. I know that when I was working down here in plan, I came in from the 25 minus 7 was into 18. That 18 mil is here. Where I went up my 15 mil up above, that's the top of that base, it's the top of the cone. So there, at one side, and there at the other. No measuring required. I'm going to join the dots with the slope lines into the corner here, into the corner here, and back to my adjustable. I can go ahead and draw the top line. The final step up here is to just add in this little central support. Now, as I said there at the very start, because I'm splitting everything in two, it's a 5mm support, so it's very, very small. I'm going to just set my set square there on 2.5mm, and then go to the left down to 0 and to the right up to 5. It's really, really small, but we'll just drop it in there anyway. That's my elevation fully drawn. What I'm going to do now, just again, I'm going to pause the video. I'm going to, first of all, I'll just highlight where my plane is right there. That's my plane. That plane is in, if I just look back here, it's in red. As I said at the beginning, when I'm looking from this direction in at the Z axis here, I'll have my blue floor underneath the object here. I'll have my green wall at my right hand side, and I have a true shape of what's happening on the red plane, which is this whole plane here in front of me. So I'm going to go and I'm going to add the color, add a couple of notes, and then once I'm back on at the video again, we're going to have a look at feeding our dimensions and our points from the plan up and the elevation down and forming our 3D view in the center. Now that we're back, you can see there that I've just added a few labels, a bit of color onto my elevation up here. As I said there before starting the elevation, and we had a quick look at this, back to this page again, the question sheet on our right hand side. As you're standing here looking in along the angle of the Z axis, sorry, on our right hand side we can see the green wall, the in vertical plane. So as we look in along on the right hand side here is our green wall. It's an edge view of the in vertical plane, and on the ground is the ground. It's a blue horizontal plane, so the edge view of the HP down there, and we have a true shape of the vertical plane. To start feeding back into our axonometric view is our next challenge here. And the first thing again to just realize is that all our projections coming from the plan are going to come in line with the line we projected from. So we projected from the Y axis originally straight down to plan, so we're going to project straight back up to elevation in line with the Y axis. Similar over here on our elevation, we projected in with the Z axis. Well, we're going to project back out from all of our points parallel to the Z axis. We're not going to go changing angles here or doing anything strange now, like coming across horizontally. We will go parallel to the axis that we based our view on. Is there any point at all that we can get started with? Well, there is, but there's not many. There's very, very few we can get started with, in fact. This point right here is the point of contact that the object makes with the green wall. The point of contact it makes with the green wall is also here. So we have something to start with. With very, very little bit. So I'm going to just drop that guy up. I know that that point right there is the point of contact the object makes with the green wall. What you might start to realize now is that that won't even be seen after. I'll just drop it in there anyway. The point of contact the object makes with the red wall is here. And where is that? That is actually at the back of this point. As we're looking at the object, this one is one in front of us, and there's one at the back as well, which coincides exactly on that point. So that is the point of contact. And you'll see the way that they cross perfectly on the axis right there. I mean, it's sitting in the corner, it's touching the floor, and it's also touching the red wall right there. So we have 2 points. The point directly opposite the contact with the green wall, through the center, and out to here is the next one I'd like to get. Now, I need to do a little bit of extending here down in plan so that I can get that. And the fourth one, I'll just extend through this line right here. So as I was saying, the point of where it touches the green wall is here, and it comes out through the center, and it comes right on out along, and it hits that point. That's the next one I'd like. What I want to see here is this, okay? I want to see that that line right there is parallel to the red wall. So I'm going to go ahead and I'm going to make it parallel to the red wall. So my x-axis here defines the angle of the red wall. So That was 45 degrees, so I can just bring that out to 45. From there, I notice the point it comes in contact with the green wall is here, and the one opposite it all the way out through is here. So what we should find is that it all coincides pretty perfectly there. So I happen to come off the back wall, off the green wall, straight out, through the center point of the object here someplace, and all the way out. I brought it reference from the front of the object here down, and from here up. The final point, I suppose, you start to realise now that I'm going to get is the one that is directly opposite the contact point with the red wall, out here. And where is that in the elevation? It comes from the centre of the object. And just let's get back to it then. We'll trace our points. So from the centre of the object down, catches the point where it touches the red wall, and it comes all the way out to here. There's going to be a freehand curve right there for the base, but I need more points. I can't start guessing my curve now already. So let's just look down at plan. I'm going to take my adjustable set square and I'm going to work with it for this one, okay? And I'm going to run out. It's kind of hard here with space now. Let's just see how I get on. So I'll take my adjustable, I'll line this up with the two, with the green and red wall there, my 90-degree corners. Now I need to divide up the base of this object. I'm going to divide it up using my 30-60 set square, but I can't just work the 30-60 set square off my T-square. I have to work it off of the parallels off of the walls. It's the most important thing we do here. Let's just go ahead and see how that works. So my adjustable right now is set in line with the green wall, and I am going 30 degrees off that. Now this drawing is going to get really busy now in the next few minutes. I'm going to have to take away my T-square every now and then to allow my set square to fit to draw some of these lines. Not too bad, there we are. So that's it, all off of that one angle. And there we have our plan broken up. I'm going to number that plan. Number it using maybe a pink one here or something. I'm going to call this, you can start anywhere you want really, but I'm going to start with one of the points I already had. Point 1, which is here, which is here. Working around to the left, so 2, 3, 4, which I already have here, touching the wall, here at the back of the object. 5 on the ground, 6, 7, which I have here, touching the right wall, the green wall, and here 7 in the corner. 8, 9, 10, which I already have here, and this one here in front, so it's 10, 4, and then it's 11 and 12. The next part of this is probably one of the more difficult, if not the most difficult thing to grasp and to understand. If you get this, you get axonometric. We've built up the difficulty of these questions from simple objects to sloped surfaces, and now onto conical objects and spheres. This is the part that we really need to understand. The dimensions in plan feed in to the axonometric. The dimensions in elevation feed into the axonometric. But also the dimensions in plan feed into the elevation because they're common dimensions. When I was trying to get this point here and this point here, I did not use my set squares. I did not measure it. And the reason I didn't measure it is I don't want to build up what's called a cumulative error. I don't want to be a 0.5 millimeter off here and a 0.5 millimeter off here on each one, and I end up building up my errors to 1 mil or more of a tolerance. What I did instead was I said that I know for a fact that I had already measured it down here, and if I had already measured it down here, I can take it on my compass and bring it up. Well, that's what I need to do again. I need to do that for every point, except of course 1, 4, 7 and 10, which we've already found. The important thing to realise here is this. The view you can see in the elevation is here. It is taken by looking directly in at the object as it sits, where we can see the green in the vertical plane on our right hand side, and we can take all dimensions from point where we're starting there. 0.7 touching the green plane is the same as 0.7 touching the green plane here, working across to 0.10 in the center and to 0.1 on the end. The widths of the object in the plan are the same as the widths of the object in the elevation. Let's just get into that point now. What I want is this. I want the distance. I want to know how far it is going to be. So from 10 working to my right, so from 10 working out towards 7, I want the distance out to number 9 and number 8. The mistake that some people might make here is this. They'll measure the distance from 10 to 9. And they'll say, okay, 9 to 8 is the same and 8 to 7 is the same. And they're linking that back to something else, a completely different topic they might have done in junior cert. Watch what will happen. From 10 to 9, from 9 to 8, and we're gone over the plane already, and from 8 to 7. And it just makes no sense. And you're not sure what you've done wrong. But what you need to realise is this. The overall width of the object here, from 1 to 7, is here from 1 to 7. It's along that central axis right there. And that central axis is parallel to the red plane. And the red plane is where we see all of our true sizes. It's true shape up in the elevation. So everything has to be dimensioned and measured straight across the object. What does that mean for us? It means this. It means that if I go ahead and I might just use sliding set squares. It's probably not worth bringing in my adjustable for this. If I use sliding set squares here, I'll join across the object from 9 to 11. I'll join across the object from 12 to 8. I don't need to do any more because 6 and 8 are going to line up, 5 and 9 are going to line up, 3 and 11, and 2 and 12. That's all I need right there. What I need to understand is the distance I'll take up to my view is this. We're looking directly in at the object here. The distance from the center of the object at 10, straight out to number 9 on the right, and 11 on the left. So 9 on the right, 11 on the left, 9's on the right, and 11's on the left. Back down to my plan again. The distance from the central line of the object out to number 8 on the right, 12 on the left. So 8 on the right, 12 on the left, 8 on the right, 12 on the left. And that's it. That is the hardest thing about axonometric, is understanding that as we view in on the object here, the dimensions that come from that green wall, and this is why I love the colour, it gives us a good idea of what we're referencing from where. The dimensions from the green wall here on the right hand side, directly out along, but the dimensions have to be perpendicular to that wall or parallel to that main axis. But the dimensions from 7 out to 8, 7 out to 9, 7 out to 10, out to 11 and out to 12. We could have, if we wanted, but it's really handy to have them all symmetrical, we could have taken everything from the wall. So 7 out to 12, from the wall out to number 12 there, would be still the same. I might just drop in the extra few points here. I'm not sure if I'll even need some of them, but directly behind 12 is 2. So 12, 2. Directly behind 11 is 3, 11, 3. I have 10 and 4 already. Behind 9 is 5. And behind 8 is 6. Time to draw the base. So we have 1, 4, 7 and 10 already. Let's just add some more points in there. I'm going to project up from the plan in line with the y-axis. So let's switch to my 5H pencil for this because this is going to get busy. I have 10, I'm going to go for 11 and 12 first of all. So up from 11 and up from 12, I'll do the two at the same time. And I'm going to come down from 11 and down from 12. Let's find the points. I'll just put a dot in them for now with the black pen. 11 up and 11 down across here. Up and 12 down across here. Now I'm going to go ahead and add some more in there. So that is 10, 11, 12 and 1. Let's go for 2 and 3. So point 2 up and point 3 up. Point 2 down is already projected with 12 and point 3 down is already projected with 11. So 2 lines up with 12. 3 lines up with 11. There. 2, 3. Okay, so we're getting our way around it now. I know that this is all going to be hidden back here from 4 all the way back to 7, and probably some of it around the right hand side as well. I'll just find the points. The 5 and 6 are going to be in there at the back of the object in the corner. No need to find them at all. The ones I would like to have those from 10 down to 7, because I'm not sure how much of it I need yet. So from 10 I want 9, I want 8, so I'll go ahead and find those two. So 9 projected up, 8 projected up, 9 projected down, 8 projected down, 9 up, 9 down, plus there, 8 up and 8 down here, 10, 9, 8. I'm going to really lightly just start forming this curve, and the only reason I'd like to do that is so that I can start to visualize it myself and see where I'm going next. So you just join all the dots with a nice smooth freehand curve if you can. And there we have that much. As I said, there's no need for that back corner. I probably didn't even need some of this here. I'm not sure yet. We'll figure it out after. We can just leave it at that. We can go on ahead then, and we can start adding in the points on this top surface here. Same process. I'm going to go ahead and grab a different color. Where is that top surface in plan is the first question. Well, that top surface right there is, we had a size 25 radius here, and then it was -7, brought us down to an 18, and then that was back up to a 20. So the 20 is this solid one, that's the sphere. It's this one right here. So this one on the hidden. And at the very start, when I was setting out this plan, I made sure that I draw the circle first of all as a full circle, and then I put in all of my hidden detail dashes, or maybe I did it the opposite way or something. But either way, I ended up with a nice light construction circle all around, so that I can actually plot all of my points on it. You could use A, B, C in this if you want. It's really up to yourself. I'm going to use numbering again, the very same. I'm going to go with the exact same numbers. 2, 3, 4, 5. One to 12 right there. I'm going to need to do the same process as I did last time. So I'm going to go parallel to that red wall of the at the back of the object. I'm going to go ahead and just take 9 and 11 again. So there's 9, there's 11, and I'm going to just take them across perpendicular across the axis of the object, and 12 and 8 as well. And I don't need any more than that. That's all I need for now. I need to transfer those measurements up here onto this object. Before I do, maybe I can add some labels up there. I have point 1 is just above point 1 here on the far left hand side of the object, so 1 is there, 1 is also here. What's at the far right then is point 7 above point 7 here. Right here in front of me is the blue point 10, and at the back of it is the blue point 4, so that right there is 10, 4. And that's all I can take for now. I'm going to take the distance out here from the center line out to number 9. 9 to the right and 11 to the left. So I have 9 to the right and I have 11 to the left. From the center line, I'm going to take my distance out. 8 to the right, 12 to the left. So it's 8 to the right, 12 to the left, and then see what lines up with what. So behind 8 is 6, so it's 8, 6. Behind 9 is 5, 9, 5. Behind 11 is 3, 11, 3, and behind 12 is 2, 5 and 2. And then it's time to start projecting. This is the point where you need to be very, very careful. You need to just make sure that you don't take the wrong references. We have the pink ones and the blue ones this time. The pink ones are on the base of the object, the blue ones are on this top of the first truncated cone. Now, I'm going to get started with points 1, 4, 7 and 10 again. So I'm going to take all 4 up there at the same time. Point 1, point 4, point 7 and point 10. You might find it much easier to do these one at a time. You might find it easier to do exactly what I'm doing here, maybe 3 or 4 at a time. It's completely up to yourself. It's personal preference really. Just make sure you get the correct points. So point 1. I like to sometimes have 2 pencils, maybe, or 2 pens for this job. Point 1 comes up on that line, point 1 comes down on that line, and that's where they cross. And I just verify it once more. Point 1 in blue, of course, comes up and I'm on the right point. Point 1 in blue, and I'm there. So that's fine, that's point 1. Point 4 is up there. Point 4. There we have that one, point 4. And again, just verify it one more time. Point 4 is on the right line. Point 4 is on the right line. Point 7. That's an easy enough one to find out there. 7 and 10. It's 10. Ends up with 7 there, and 10 comes down here. Perfect. So that's my first 4 done. And again, do whatever method you like here, one at a time or all projected up. What I'm going to do now is I'm going to take all the ones that I need. And just like on the base, we did 7, 8, 9, we had 10. So we had 8, 9, 11, 12, 2 and 3. I'm going to go ahead and project them all. So 8, 9, 11, 12, 2 and 3. From the elevation, 8 and 6 are there, 9 and 5, 10 and 4 is taken already, 11 and 3, 12 and 2. And now it gets busy. So this time you really need to take care when you are tracing your points. I'm going to start here at the far right hand side with number 8. And I'm going to do my best not to make a mistake here because this is getting busy. 8 is on that line. I hope 8 is on that line. It's point 8. I want to add numbers in just now. 9 on that line. 9. There. 10, 11. Should be a bit easier. Seems to be a bit more open around here. 11. 12. 'I didn't take 12 far enough up from plan. So 12 from plan on that line. 12. Number 1 is done. 2. That line. And it lines up with 12, of course. So it's right there. and finally tree just outside 2. Yeah. Now there's that number of points there in the blue surface. Now I think that the value of using a bit of colour here is absolutely huge, because it just means that I was looking there for a second saying 1, 2, and that's 4 down there. How could 3 be up here? But it's just so obvious when you have the colour there. You just won't make the mistakes and make the wrong links and connections. Now I'm going to have to do a little bit of tidying up in that curve there after, but for now it's fine. The next job I'm going to do is I'm going to go ahead and draw in the sphere. So the sphere might seem like something that's so difficult to do, but it's actually really easy, because a sphere appears as a circle in every view. Whether it's a 2D view or a 3D view, it's a circle and that's it. If I just maybe grab a yellow colour here of a fine liner and just work through the sphere part. So the centre of the sphere is here in Plinth. The centre of the sphere is up here in the elevation, right there. The size of the sphere is right there in the elevation, and it's there in Plinth, and it's from the centre we draw the sphere, and that's it. So for something, when you start working with curved objects and you start working with cylinders and cones, you start thinking about how difficult it is, and then you see what a sphere is like, and you realise that it's a very easy one of the easiest things you could possibly be asked in a question. Now, because the that little centre support is so small, and it's only, what is it, a radius of 2.5 millimeters, I am no way am I going to go, I'm not even going to draw it here in Plinth. I should have a little 5mm circle there. I'm not going to draw it in. I'm not going to attempt it even. If it was something more substantial, you might be expected to break it up again and take your reference points and bring them down. But for 5mm or 10mm, that's not going to happen. So we leave that out. What I'm going to do now, I'm going to just pause the video. I'm going to clean up these curves for a little bit and just talk to you about the very last part of the drawing. The last part of this drawing that I'm going to do is I'm just going to outline the planes. And again, just like in the previous tutorials in this, I think that it's invaluable to see the colour. It's invaluable to put a limit on these planes, even though we know the planes are an unlimited size. They're sized to suit the object. So in this case, the object for me is quite small. If we decided to change it up and draw something really large, the planes adapt to suit the size of the object. So I think it just looks so much better though, just to put a limit on those planes. And the 3 axes as well, I like to just put that little bit of an extra line over them, but just over the portions of them that are visible, so we can just see, we can see, and that's it. And then we can only see the object from there on. Now I'm just gonna, once again, I'll pause the video for a few seconds. I kind of cleaned up my curves a little bit there. I think they'd be as good as you might be expected to do in a leave and search question. They're not perfect, but they're not bad. What I'm going to do next is I'm going to go ahead and add the blue onto the horizontal plane here, the floor. Just add my labels. There's the HP. I'll put the blue on the floor. I'm going to put the corresponding red up here on the vertical plane that I can see over here in my main elevation, and then this is my end vertical plane, my EVP right here. And what have I got for that? I have green, which is the edge view color that is given there. I'm also going to maybe add just a little bit of shading onto the object itself in the 3 views, whatever can help me to visualize what's happening and to create the links between the 3 views would be nice to add it in here. These sheets will serve as a really nice reference as well to come back to when you're working on further questions. So again, I'll pause the video, I'll add in my bit of colour around my planes and onto the object itself, and we'll have one final look at it before we sign off. That's shaded in, we can kind of have a good look at what the 3 views are like, how the 2D views both feeding into our 3D view and what it all ends up looking like. I think what's obvious to me is that that little stand there is definitely missing. It really should be in there. It's just now I know that scaling down the drawings I did, there was no chance of getting it in there, but you know, that would be the far left side, which would be somewhere just out here at about 5 mil. To me, it looks like it should just about be present there someplace. And you know, just for the sake of finishing this off and having it like a nice poster that could go up on the wall, I'm just going to lightly just put a little base in there. And I think it'll just finish this off nicely. As I said, if it was any bit larger, it might actually be worth doing this correctly. But for the sake of what we're dealing with, there it is, just dropped in. It just gives that connection between the sphere and the base down in this 3-dimensional view here, in this axonometric view. I think that after the 3 videos, hopefully the isometric, trimetric and diametric, taking some very simple objects and bringing it on up to something quite complex like this one, I'm hoping that we'll have a good understanding of this topic. Through the use of the little bit of colour and shade and the labels, it just really helps with developing an understanding. Instead of learning the theory and learning a procedure for taking a width with a compass every time, that will never follow through to a situation where your understanding is tested. That will only work if it's completely procedural. If it's something very basic and straightforward that you've done 20 times before, maybe you will know how to set your compass and how to bring it up. But if you understand, and if you've used your labels, and if you know that the edge view of the end vertical plane is along here in the green, which is also along here in the green, and that everything can be referenced out from there, which is coinciding with the references out from there in the elevation, and then you can just bring all your points up to meet. Well, look, the understanding is the key. That is where it all comes in, and I think that's where our colour, our labels and our notes also comes in. I hope this video helps. It's probably one of the hardest objects that it will be seen in these current 8 worksheets here, and feel free to give me any feedback in the video or any further questions you might happen to have, and there'll be more on the way for Axonometric. Thanks very much for tuning in. Hope you've enjoyed the video.